Good morning, children. Today we are going to learn about 11th standard chemistry. The unit is 8th unit, physical and chemical equilibrium. Okay. Already I teach in this lesson what is the topic, what is chemical reaction, and what is homogeneous and heterogeneous reaction, and what is the law of mass action, then the relationship between Kp and Kc. Then I continue, I teach the next topic is application of equilibrium constant. Okay, children. So all of you take your book, page number 9. All of you take your book, page number 9 and take your note. You write the classwork and homework properly. Okay, children. So the application of equilibrium constant is the first point is predict the direction in which the net reaction will take place. So is the direction. So what is the general chemical reaction? What is the general chemical reaction? Yes, A plus B, the reversible reaction of C plus D. Okay, so A plus B to give C plus D is a forward reaction. Is a forward reaction. Then C plus D to give A plus B is a backward reaction. Okay, backward reaction. So is the direction, is the forward reaction, and backward reaction is the direction of the reaction. So what is the first point? Predict the direction in which the net reaction will take place. Okay. So predict, what is the meaning of predicting? What is the meaning of predict? So in this predicting, the meaning is kanithal. Okay, predict the meaning is kanithal. Okay, children. Then, so in the application, so all of you see in your book 8.7, the application of equilibrium constant. The first point, predict the direction in which the net reaction will take place. So the direction is the chemical reaction present in backward reaction or forward reaction. Then predict the extent of the reaction. So the extent of the reaction means is the quantity. Okay, is the quantity of the reaction. So the extent of the reaction is quantity of the reaction. Okay, so one more question, what is meant by extent of a reaction? So in in physical chemistry and chemical engineering, extent of a reaction in which quantity that measure the extent to the reaction proceed. Okay, so in this extent of the reaction is usually defined is the unit is mole. Okay, the unit is mole. The extent of the reaction, the unit is mole. Okay, children. Then, so the third point is calculate the equilibrium concentration. So in the concentration, so already I teach in the concentration in the square bracket is denoted in the square bracket. So calculate the equilibrium concentration of the reactant and product. So in this reactant concentration and product concentration. Okay, children. So the reactant concentration and product concentration. Okay. So what are the applications? So the application of equilibrium constant is the first point is predict the direction in which the net reaction will take place. Then the second point, predict the extent of the reaction. Then the third point, calculate the equilibrium concentration of the reactant and product. Okay, children. Then, so all of you take your next page, page number 10. What is the next topic? Continue the topic is predicting the extent of a reaction. Okay, predicting the extent of a reaction. So in this predicting the extent of a reaction, there are three cases or three types. Okay, three cases or three types. So in the first case, the first type, in that first type, the Kc value, in the K value. So the simple, so what is the meaning of K simple? What is the meaning of K simple? So K is equilibrium constant. Equilibrium constant. Okay, K is equilibrium constant. Okay. So in the first case, all of you see in your book, table number 8.2, the value of Kc value. Okay, in the first case, Kc is greater than 10 power 3. In the first case, Kc value is greater than 10 power 3. So in the simple is greater than. Okay, so Kc is greater than Kc is greater than 10 power 3. Okay, so that means is the forward reaction is present. Okay, so the Kc is greater than 10 power 3. So it is the highly yield product. Okay, so what is the first point? It is the highly yield product. It is the highly yield product. Okay, children. So in the first case, on the first type, the Kc is greater than 10 power 3. Is the first point is high yield product. Then the second point is the reactant is greater than product. Okay, reactant, the concentration. So in the concentration means the square bracket. Okay, reactant. Okay, reactant is greater than product. Okay, so in this case the formation of higher than product. In the product is the formation is higher. The formation is higher amount. Okay, children. So in the Kc is greater than 10 power 3 in the reactant to product. So the reactant to product means A plus B is a reactant to give the product is C plus D. Okay, so in the A plus B to give the answer is C plus D. Okay, C plus D. So in the reactant to product to form the yield is very highly yield is present. So in this reactant is greater than product. So in this reaction is nearing to the completion. So what is the next point? So in the next point is the reaction is nearing to the completion. Okay, nearing to the completion. Okay, children. Then, so in this reaction is a forward reaction is favored. Okay, in this reaction is forward reaction. Okay, forward reaction is favored. Okay, then so in this reaction examples. In this reaction example, so in the first example, the formation of HCl at 300 Kelvin. Okay, the first example is formation of HCl at a temperature 300 Kelvin. So what is the reaction? HCl formation reaction H2 gas molecule. So in this reaction is a homogeneous reaction. So H2 gas plus Cl2 gas. The reversible reaction 2 moles of HCl gas. Okay, 2 moles of HCl gas. So in this reaction is the Kc value is 4 into 10 power 31. Okay, 4 into 10 power 31. Okay, children. Then next, so in the second example, oxidation of carbon monoxide. Okay, oxidation of carbon monoxide at 1000 Kelvin temperature. So what is this reaction? So carbon monoxide. Okay, carbon monoxide. So 2 moles of carbon monoxide gas molecule is react with oxygen gas to give the formation of 2 moles of carbon dioxide gas. Okay, so in the second reaction, 2 moles of carbon monoxide gas molecule is react with oxygen to formation of 2 moles of carbon dioxide gas is formed. So in this reaction Kc value. So in this reaction Kc value is 2.2 into 10 to the power 22. Okay children. So this is the first type. So in this first type Kc is greater than 10 power 3. So in this reaction is highly yield to form product. Okay, highly yield to form product. So the reactant and product in the formation is higher. Okay, the product is formed is higher. Okay, so in this reaction is nearly to the completion. Then the forward reaction is favored. Okay, so in this reaction the forward reaction is favored. Then the example of this reaction, the first example, the formation of HCl at 300 Kelvin. So in this reaction H2 plus Cl2. Okay, hydrogen gas is react with chlorine gas to form of 2 moles of hydrogen chloride. So in this Kc value is 4 into 10 to the power 31. Then the second example, the oxidation of carbon monoxide at 1000 Kelvin temperature. So in this reaction, 2 moles of carbon monoxide is react with oxygen gas. The reversible reaction is 2 moles of the formation of 2 moles of carbon dioxide gas. So in the Kc value is 2.2 into 10 to the power 22. Okay children. So this is the first case. Then the second case. So in the second case, so in the first case is Kc is greater than 10 to the power of 3. So in the second case Kc is less than 10 to the power minus 3. So in the second case is Kc is less than 10 to the power minus 3. Okay. So in this less than 10 to the power minus 3 means, so in the greater than 10 to the power 3 means high yield product. Okay. So in this case less than 10 to the power minus 3 means is low yield product. Okay children, low yield product. D. Low yield product. Then the next step is the reactant is greater than product. The concentration. So in the concentration of reactant is greater than product. The concentration of product. So in this reaction make a little progress. Okay, so in this reaction it's make a little progress. So the reaction, so all of you write in your classwork note, make a little progress. Okay. So what is the first point? The Kc is less than 10 to the power minus 3 is low yield product. Then the reactant is greater than the product. Then the reaction makes a little progress. So in this reaction is forward in reverse reaction. Okay, so the reverse reaction is favored. Reverse reaction is favored, or the reverse reaction or backward reaction. Reverse reaction or backward reaction. So in this reaction example. Okay, so what is the example? So in the first example, the decomposition of H2 water at 500 Kelvin. So the decomposition of water at 500 Kelvin. Okay. So in this reaction, water reaction, decomposition of water reaction. So 2 moles of H2O gas is a homogeneous reaction. The reversible simple. So 2 moles of H2 gas plus oxygen gas. So what is the Kc value? Kc value is 4.1 into 10 to the power minus 48. Okay, so the decomposition of water at 500 Kelvin, 2 moles of water to formation of H2 gas and oxygen gas. So the Kc value is 4.1 into 10 to the power minus 48. Okay. Then the third case. So in this third type or third case, the Kc value in between the value of, in the Kc value in between the value of 10 to the power minus 3, 10 to the power minus 3 and Kc and 10 to the power 3. Okay, so in between the value of 10 to the power minus 3 and the value of 10 to the power 3. Okay. So in the first point, the significant the quantity of product and reactant. So what is the first point? Is the significant quantity. So the extent of the reaction. Okay, quantity of product and reactant. Okay, product and reactant. Then the Kc value 10 power 3 means forward reaction. Okay, Kc value 10 power 3 is the forward reaction. Okay children, so 10 to the power 3 is a forward reaction. Then the Kc value 10 to the power minus 3 is a backward reaction or reverse reaction. Okay. So in the Kc value 10 to the power 3 means forward reaction. The Kc value 10 to the power minus 3 means backward reaction or reverse reaction. So in the Kc value 10 to the power minus 3, Kc value 10 to the power minus 3 and 10 to the power 3. Both the reaction of forward reaction and backward reaction. Okay, so both the forward reaction and backward reaction make significant progress. Make the significant progress. Okay children. So in the next point, so the neither the forward or reverse reaction is predominant. So in this reaction example, so the example is dissociation of bromine monochloride. In the example, the first example is dissociation of bromine monochloride. Is the simple is BrCl. Okay, bromine monochloride. So the dichloride means Cl2, monochloride only one chlorine is present. Okay children, so BrCl, bromine monochloride at 1000 Kelvin. Okay, at 1000 Kelvin. At 1000 Kelvin. So in this reaction, 2 moles of bromine monochloride is the gas molecule in the reversible reaction to form bromine gas plus Cl2 gas. Okay, bromine gas and Cl2 gas. So in this Kc value is 5. Okay, then the next reaction, the formation of hydrogen iodide. Okay, in the formation of hydrogen iodide. At the temperature 700 Kelvin. So in this reaction, this is the general reaction. Hydrogen gas is react with the iodine gas to formation of 2 moles of hydrogen iodide gas. So all the reaction is a homogeneous reaction, gaseous state reaction. So in this case, C value is 57.0. Okay, 57.0. Okay. So in the first case, second case and third case. So what is the first case? So in this first case, the Kc is greater than 10 power 3. So in this reaction is highly yield product. So in this reaction is nearing to the completion. So in this reaction is forward reaction. In this reaction is forward reaction. Example, the formation of HCl at 300 Kelvin reaction. Okay. Then the second type. So the second type is Kc is less than 10 to the power minus 3 is the low yield product. Low yield product. Then the reaction makes a little progress. In this reaction is reverse reaction or backward reaction. Okay, reverse reaction or backward reaction. The example is decomposition of water at 500 Kelvin. Then the third case. So the third case is Kc value is between. Okay, Kc value in between 10 to the power minus 3 and the value of 10 to the power 3. So in the significant, the quantity of the extant reaction is product and reactant. So in the Kc value 10 to the power 3 means the reaction is forward reaction. Kc value the 10 to the power minus 3 means the reaction is backward reaction. Kc value 10 to the power minus 3 and 10 to the power 3, the value is the reaction is both the reaction of forward reaction and backward reaction make the significant progress. So the example is dissociation of bromine monochloride at 1000 Kelvin temperature. So bromine monochloride BrCl, 2 moles of bromine monochloride is react to the formation of bromine gas and chlorine gas. Okay children, so this is the predicting the extent of the reaction. Okay, so one example, all of you see in your book page number 10. Consider the following equilibrium reaction and relate the equilibrium constant. So in the first reaction, nitrogen gas. Okay, nitrogen is react with oxygen to form 2 moles of nitrogen monoxide. So you write the Kc value K1. Okay, K1 means Kc value. So you write the K1, K2 and K3 value. So in the example of the reaction, so in the first reaction, nitrogen N2 plus oxygen O2 is the reversible reaction of the formation of nitrogen monoxide. Okay, so you write the K1 value. So what is the K1 value? So K1 is equal to forward reaction is divided by backward reaction. Okay, so you write the formula NO concentration 2 divided by N2 O2. Okay, this is the K1 value. Okay, then the second example. So in the second example, nitrogen monoxide is react with oxygen in the reversible reaction of to formation of nitrogen dioxide. 2 moles of nitrogen dioxide. Okay, so nitrogen monoxide is react with oxygen to the formation of 2 moles of nitrogen dioxide. So you write the K2 value. Okay, you write the K2 value. So in the K2 value, all of you write. So in the forward reaction is divided by backward reaction. So in this forward reaction, NO2 nitrogen dioxide in the concentration 2 divided by nitrogen monoxide and oxygen. Okay children, then the third example. So in the third example, nitrogen gas is react with 2 moles of oxygen. Okay, nitrogen gas is react with 2 moles of oxygen to form 2 moles of nitrogen dioxide. Okay, so in this reaction you write K3 value. Okay, K3 value. So you write the K3 value. So in this K3 value is K3 value, the forward reaction is divided by backward reaction. So NO2 concentration 2 divided by N2 plus O2 oxygen concentration 2. Okay, so you calculate K3 equal to K1 into K2. Okay, K3 is equal to K1 into K2. So you write the formula K3 is equal to K1 into K2. Okay, children. So what is the K1 value? So the K1 value is NO concentration 2 divided by N2 plus O2. You write the K3 value. K3 value NO2 concentration 2 divided by N2 plus O2 concentration 2 is the K3 value is equal to K1 value. So what is the K1 value? NO concentration 2 divided by N2 plus N2 into oxygen. Then next K2 value. So what is the K2 value? NO2 concentration 2 divided by NO2. Okay, children. So first reaction you write the K1 value. So the K1 value, the forward reaction is divided by backward reaction. Then the K2 value is forward reaction is divided by backward reaction. Next in the K3 value. So the K3 value is equal to K1 into K2. Okay, children, this is the example problem. The next topic is the predicting the direction of a reaction. Okay, what is the next topic? Predicting direction of a reaction. All of you write the heading. Predicting the direction of a reaction. So what is the direction? So the direction is forward reaction or backward reaction. Okay, forward reaction or backward reaction is the direction. Okay, so you write the consider a general homogeneous reaction. You write consider a general homogeneous reaction. So in the general homogeneous reaction formula, XA plus YB, the reversible reaction simple, LC plus MD. Okay, so in this reaction is depends upon the Kc value. Okay, in this reaction is depends upon Kc value. So this the Kc is the equilibrium constant. Okay, is the equilibrium constant. So you write compulsory. You write the first reaction is the general homogeneous reaction. Okay, general homogeneous reaction is XA plus YB is the reversible reaction to formation of LC plus MD. So in this reaction is depends upon Kc value. So in this Kc value is conversion of reactant into product. Okay, the conversion of reactant into product. Okay, so all of you write in your classwork note the conversion of reactant into this is the reactant, this is product. Okay, so the conversion of reactant into product, the variation of the concentration. Okay, the variation of the concentration. The variation of concentration. So concentration is a square bracket. Okay, concentration. Then so in this reaction do not reach the equilibrium. In this reaction do not reach the equilibrium. So in this condition is called a non-equilibrium state. Okay, so in this the conversion of reactant into product, it is do not reach the equilibrium. In this reaction do not reach the equilibrium. So in this case is called, so it is called non-equilibrium. It is called non-equilibrium state. Okay, children, so this is called non-equilibrium state. Okay, so what is the general reaction? XA plus YB the reversible symbol is LC plus MD. So it is the depends upon Kc value. Then the conversion of reactant into product, the variation of concentration value. The variation of concentration value then do not reach the equilibrium. So in this reaction, the reactant to product is do not reach the equilibrium. So it is the called non-equilibrium state. Okay, so in this non-equilibrium state is calculated the product active mass and reactant active mass. So you write the reaction is called stoichiometric coefficient. Okay, so in this non-equilibrium state calculate the product active mass. Okay, product active mass and you write the product active mass and reactant active mass. You write the reaction is called stoichiometry coefficient. Okay, so the product active mass, and reactant active mass active mass. So you write the reaction. Okay, you write the reaction is called stoichiometry coefficient. Coefficient reaction. Okay, coefficient reaction. So in this non-equilibrium condition reaction. So what is the reaction of non-equilibrium condition reaction? Is the XA plus YB, the formation of LC plus MD is the non-equilibrium reaction. So in this non-equilibrium reaction, the product active mass, product active mass ratio. Okay, product active mass ratio is divided by reactant active mass ratio. So what is the formula? You write the formula: C concentration L, D concentration M divided by A concentration X, then B concentration Y. Okay. So in this reaction is reaction the value is denoted is Q. In the reaction is denoted the value Q value. Is denoted the value Q. So you write the next formula is C concentration L, D concentration M divided by is A concentration X, B concentration Y. Is denoted the letter Q. Is denoted the letter Q. Okay. So as the reaction proceed, the variation of the concentration value and the variation of Q value. Okay. As the reaction proceed, the variation of concentration value and the variation of Q value. Okay. So in this reaction attain the equilibrium, do not change the concentration. Okay. So in this reaction, this general homogeneous reaction, the reaction attain the equilibrium. The reaction attain the equilibrium, do not change the concentration and do not change the Q value. Okay, what is the last one? Do not change the attain the equilibrium reaction, do not change the concentration and do not change the Q value. Okay, so in this K and Q value, the Q can be used to determine which the direction of your reaction will shift to reach the equilibrium is three cases. Okay, so what are the three cases? So in the first case is K is greater than Q. If K greater than Q, so in this reaction will proceed the forward reaction. In this reaction proceed the forward reaction. Okay. So in this forward reaction is converting the reactant to product. Is converting reactant into product. Reactant into product. Okay, so this is the first case. Q greater than K value. Okay, so the K value is greater than Q is the forward reaction, and then converting the reactant into product. Then the next case, the second case, K is less than Q. Okay, K value is less than Q. So in this reaction is reverse reaction. Okay, the reaction will proceed. The reaction will proceed is reverse reaction or backward reaction. Okay, reverse reaction, a reverse reaction or backward reaction. So the converting the product into reactant. The converting product into reactant. Product into reactant. Then the third case. So in this third case, Q is equal to K. Okay, Q is equal to K. Okay. So in this system is already at the equilibrium. Okay, so in this reaction is equilibrium reaction. Equilibrium reaction. Okay, children. So in the predicting the direction of a reaction will be three cases. So what are the cases? So the first cases, the K is greater than Q. So in this K greater than Q is forward reaction, then the converting reactant into product. Then K is less than Q. Less than Q is reverse reaction. Okay, reverse reaction or backward reaction, the converting product into reactant. Then the third case, Q is equal to K, is a equilibrium reaction. Okay, children. So today we learn about the predicting the reaction, predicting the extent of the reaction and predicting the direction of the reaction. Two topic you learn today class. Okay, so predicting the extent of the reaction and predicting direction of the reaction. So in the predicting extent of the reaction is three cases, is Kc is greater than 10 power 3 and Kc less than 10 power 3 and Kc value in between the value of 10 to the power minus 3 and the value of 10 to the power 3. The next um, what is the topic? Predicting the direction of a reaction. So first you write the general reaction, homogeneous reaction. The homogeneous reaction, Xa plus Yb, the formation of Lc plus Md. So in this reaction depends upon the Kc value. Then last you write the Q value. So what is the Q value? Is the product divided by reactant. That means the product active mass ratio divided by reactant active mass ratio. So in this predicting the direction of a reaction is three cases. So in the first cases, K is greater than Q is the forward reaction converting reactant into product, and then K is less than Q, reverse reaction converting product into reactant. Then the third case is Q is equal to K is a equilibrium reaction. Okay, children. So all of you take your book, your book back question. Now your homework. Okay, your homework, your book back question. Question number. Okay, book back question number 34, 35, 37 and 38. Okay, the next additional question, define equilibrium constant. Define equilibrium constant. Okay, this is your homework. So all of you write your homework. your book back question number 34, 35, 37 and 38. In the additional question, define equilibrium constant. Okay children, so all of you write in your note, all of you study and write in your homework note. Okay children, thank you.